Welcome back to P3. Today we are looking at inverse trigonometric functions, so unit 3.5. So you've probably already been using these in your calculators for the last few years, kind of unaware. If you think of the inverse of sine in your calculator, that will show up as sine to the minus 1, inverse of cos, and inverse of tan. So these three in your calculator, sine to the minus 1, cos to the minus 1, tan to the minus 1, and they are what enable you to use that inverse function to get from one value back to your angle. So essentially to go from your y value, your range, to your x or your theta value on that domain. Now the way we actually write the inverse is like this. So the inverse of sine is written as arcsin. So this would be the inverse of sine x, the inverse of cos x, and then the inverse of tan x. And that's how we go ahead and write them. Okay, so the inverse of sine x would be arcsin x, and so on. Now, before we go any further and we start looking at the graphs, I think it's important just to think about what's happening as well in terms of why we need to limit our graphs. So if I think of a rough diagram for my sine x graph, something like this, and carrying on in both directions. Okay, it's not perfect, but just to get an idea. Now, if you remember previously, you can only have the inverse of a function that is 1 to 1. And obviously the sine graph is not 1 to 1. So what we need to do is we need to cut it off. Now, I can't cut it here and here because that's not 1 to 1. So the easiest place to do it is between these two values. So essentially at 90 degrees, or pi by 2, and negative 90, or negative pi by 2. So that is where I would cut my graph off. So, I'm essentially not worried about anything either side of these values. Okay, and that's an important concept just to understand. If you remember back, it has to be 1 to 1. So this is how I would use this part of my sine graph to create my arcsine graph. It's also why when I do the inverse of like a negative number, say like minus a half, in my calculator, you'll see that you're calculating returns. So if I did like the inverse of sine of a half, then it would return negative 30 degrees. Okay, so if I'm using that sine function, I get both positive and negative values coming out. And you'll see in a moment that that doesn't happen for the cosine graph or the arccos graph because, well, we'll have a look at the graph, but you'll see in a second. Let's rub this one out. So just very quickly, here's a quick bit of the cos graph, the cosine graph. And you can see for me to have a 1 to 1 section here, I need to go through this point. So this is from 0 to pi. And then like the other one, everything outside of that I don't need. Just rub that off there. But that's what I'm looking at. And obviously these I didn't mention on the other one. It is still from minus 1 to plus 1. So when you find your inverse graph, your axes do swap around. So, the inverse of cos is going to be between 0 and pi, and minus 1 and 1. And the inverse of sine was between minus pi by 2 and pi by 2 for 1 to minus 1. So you can see then how that works with the calculators as well. Okay, so here is back to a cut of our sine graph. and I've drawn in the line y equals x. So when I'm looking for the inverse, it's always in a reflection of the line y equals x. So my graph will look something like this, and like this, what I've got in red here. Okay, and it's just a reflection in the line y equals x. Now, normally on your previous axes it was between 1 and minus 1 on the y, so this time is between 1 and minus 1 on my x values. And then on the original x value, the original domain was between minus pi by 2 and positive pi by 2, and that is now my range. So my range and my domain have swapped round when I'm looking at the inverse. Okay, so that's just a very quick way of how we do it. We need to cut the graphs down to 1 to 1. We draw the line y equals x, and then we reflect it. And then just remember all your important points, and remember that your domain and your range will switch around for the inverse. I'll pop up the graph so you can have a quick look. I won't actually draw them out for you. Okay, let's look at an example. Okay, so first thing you want to think about is that you need to know all your common angles, the ones that we use a lot. So you should know your 30 and 60 degree. And your 45 degree. Okay, so these two are important, these two triangles, along with 90 degrees and multiples of that, so 90, 180, 270, 360 and so on. Okay, so here's my first question. It's root 2 over 2, so you've got to recognize what that is. So it's from this graph here, we've got sine. If I think of sine 45 is 1 over root 2. So if I'm thinking sine 45 is 1 over root 2, so that means that sine 45 is root 2 over 2. Okay, now this is almost what I want here. We've just got the minus. So let's have a look at how we kind of approach the actual question. So I've got this little bit of information. I'm just going to pop it down there out of the way. And let's start the actual question, because now what you want to do is say let y equal that. Then what it means is that then, as arcsine is the inverse of sine, and you can manipulate your equation by using inverses, this is the same as then saying that sine y is equal to this negative root 2 over 2. Okay, and that's what we're kind of looking at here. Now, I've already worked out down the bottom that 45 degrees is root 2 over 2. So if you think of your cast here, there's my 45, and here is my cast rule. Now, sine is going to be negative in these two sections. However, arcsine is only possible between minus 90 and 90 degrees. So that means that I'm essentially getting rid of this part of my cast. So it's only in these two sections, so I'm only left in this fourth quadrant. So this has got to be minus 45 degrees. Okay, so my value of y here is my 45 degrees, negative 45, or in terms of radians would be negative pi by 4. So my arc sine minus root 2 over 2 is negative pi by 4. And that value is the value you would get if you put this into your calculator. Okay, let's have a look at part A. Start off with what's inside, so arc cos of 0 equals, so let's make it y equals, so that means cos of y equals 0. So we know this happens when y is 90 degrees or pi by 2. Then putting this back into my original, that means I've got cos of 90 degrees, which of course is going to be 0. Okay, so that's what we've got. So cos arc cos 0 equals 0. They kind of cancel each other out because you're doing an inverse of an inverse. Yeah, because the inverse of cos is arc cos. So you do something to it, then you do the reverse to it, so you stay in the same place. Now this one's a little bit different. So we got arc cos of negative a half. Again, think of y equals, so you're thinking cos y equals minus a half. So you should know this. This will happen, if I'm thinking of the positive ones, it happens in cos is 60 degrees. So the negative is going to be negative 60 degrees. That's what I'm looking at here, negative 60 degrees, or negative pi by 3. Now this might have been my initial thoughts if I rushed into it and I carried on going, okay? But as it happens, arc cos, that has a range between 0 and pi, and neither of these answers are between 0 and pi. So there is a bit of a mistake here, a bit of an error. So let's go back and let's think about the cast diagram. Okay, so between 0 and pi means I haven't got this part of my cast diagram. I've just got this section. Okay, now because of the half that's come from here, I know it is 60 degrees, but for it to be a negative a half would mean it needs to be in this section. So 180 minus 60 is 120 degrees. So in actual fact, my value of y is 120 degrees, or 2/3 pi. Okay, so it is important that you do remember your range of values here. Okay, very, very important that you remember that. So, back to the question. Now we've got 120 degrees. I'm going to keep doing it in degrees just because I think it's easier when I'm explaining. So now I want to find sine of 120 degrees, and this is then going to take me back to root 3 over 2. Okay, it's the same answer as sine of 60 degrees, and in this quadrant sine is positive. So while cos was negative, sine is positive in this quadrant. And there is my final answer there. So it's positive root 3 over 2. Okay, have a little look through this. It is very easy to make silly mistakes on this. You just need to be aware of your limits. Okay, so when you're dealing with arc cos, arc sine, arctan, you just have to understand where the limits lie. Okay, so starting with the arcsine x equals k, that means that x would equal sine k. Now remember, we're already limited with k is between 0 and 90 degrees, that pi by 2. That means that the values of x can only take a value between 1 and 0. That's all that's going to give me an angle between 0 and 90 degrees. Now, for part B, let's start with this. So from the last one, we got sine k equals x. Now, way of linking sine and cos together is with sine squared. So sine squared k plus cos squared k equals 1. Sine k is x, so sine squared k is x squared. And we have to have it in terms of x. So we want cos squared equals 1 minus x squared. Cos k equals square root of 1 minus x squared. Now, I would be thinking of plus and minus here, but think of which quadrant it's in. It's between 0 and 90 degrees. In that quadrant, cos is positive. Well, everything's positive, so we want the positive version of that there. And that's part 1 done. Now, B part 2, we want to find tan. So tan k is got to be equal to sine k over cos k. Now, I already know what sine k is, and cos k we just worked out to be the square root of 1 minus x squared. So this is going to be x over square root of 1 minus x squared. Now, for part C, if we're looking at our answers, so if it's between 0 and minus 90 degrees, this is that fourth quadrant. Cos is positive in there, so cos k would still equal 1 minus x squared, and it'd still be positive, so no change. And by the way we work out tan, it's still going to be the same sign, because that it comes from the question, and since there's no change to the positive, then there's no change to tan as well. So in this case, there would be no change in my answers to part B. Okay, straightforward arcsin graph. Should know what this looks like now. It kind of looks a lot like a x cubed graph, doesn't it? 1 minus 1. Oh. Should be number 2 there. And there we are, done and dusted. Don't forget my x and my y. Range here is between minus pi by 2 and pi by 2. It doesn't ask for the domain, as that's already in the question there. Okay, so g of x is f2 of x. So this is a stretch in the x direction, scale factor 1/2. So it should look very much like the last one. Same kind of shape, maybe a little bit steeper, because this time it is between 1/2 and minus 1/2. Still between pi by 2 and minus pi by 2. And there we have our quick graph done. So part C, define it in this form. So gx, now it's f of 2x, so looking at the f of x graph, and we're just replacing sine x with sine 2x. Very simple. The domain we got from the last part, the sketch, so you should already know that is now between minus 1/2 and plus 1/2. So let's look at it. We want the inverse, or g to the minus 1, so let y equals arc sine 2x. Sine y is therefore 2x. A half sine y is x. So remember, when we find in these inverse functions, we rearrange to make x equals, and then when we put it in, the y will become the x. So g to the minus 1 of x is a half sine x. And then x will be between pi by 2 and minus pi by 2. Remember that the domain and the range switch places. Okay, prove from 0 to 1 arccos x equals arcsin root 1 minus x squared. So we've done something similar to this, or looked at something similar. So let y equals arccos x. So cos y equals x. Then move that over. Using sine squared y plus cos squared y equals 1. Then substituting in, we're going to get sine squared y plus x squared equals 1. So sine squared y equals 1 minus x squared. Sine y equals root of 1 minus x squared, which will be positive because it's between 0 and 1, and then y equals arcsin root 1 minus x squared. Okay, and if you compare y equals up here with y equals here, that means that therefore arccos x equals arcsin 1 minus x squared. And just to be clear why it was positive, in case it wasn't obvious, remember that x is between 0 and 1, which means that y will need to be between 90 degrees and 0 degrees. Think of your graphs, okay? Now for part B, this is all about the range, and if you look at what's happening between 0 and minus 1. So here are my two graphs, and when I look between 0 and minus 1 of my arccos, you can see that we go between pi by 2 and pi, whereas if I look between 0 and minus 1 of my arcsine, we're going between 0 and negative pi by 2. What this means is that if I had an x value between 0 and 1, okay, and I looked at it, say we pick a half, when I look up, it's going to hit a value between pi by 2 and pi. Whereas if I look, say, at the same value here, on the arcsine, it's going to hit a value between 0 and minus pi by 2, which means that this will never equal this for the same x value. Okay, so it's just about explaining that, explaining the ranges. An alternative approach would be to pick a specific x value and substitute it in to show that it doesn't work. So a counter example, okay, where you just pick a value that you know, nice and easy value, that's going to give you an answer here, and you show that they do not equal. So you've got two options there. Hopefully you enjoyed the video and you found it useful. If you did, please like and subscribe to my channel, and if you're new, welcome. You'll see that I will be producing new videos pretty much every day. There should be a video dropping from one of the modules.